Hello. We don't know whether you've come here.
Do people know AI coffee break?
Yeah, and can you turn up the volume a little bit, Roger, too?
Yeah. There you go.
I think this group knows AI copy.
Okay. Yeah, I mean, it's a little casual at times. I don't understand the need for the little coffee bean thing, but there's not a lot of videos on ChatGPT, so this was one of the earlier ones I found. So.
Because of ChatGPT, or because you want to know about research on chatbots in general these days? Then let us tell you how we came across the idea of making this video. A while ago, I was reading this incredible paper from Deepmind proposing a new chatbot called Sparrow. While we were sitting on this paper and planning the video, here it was, the mighty ChatGPT from OpenAI changed the landscape of the internet. How exactly you can see in plenty other YouTube videos, we focus on the research here. But disappointingly, ChatGPT did not come with an extra paper release. On the other hand, Sparrow from Deepmind has a paper, but they don't let us play with the model. And now that everybody's interest is peaked around chatbots, we really want to discuss Sparrow, especially since it was trained very much like ChatGPT, but with even more objectives, because it can follow explicit rules and can make Google searches to provide evidence for its answers. Since ChatGPT did not do such a good job at telling me what to say to you in this video, Miss Coffee Bean will give her best shot at explaining ChatGPT from OpenAI and Sparrow from Deepmind and make a comparison. But first, let's thank Cohere for sponsoring today's video. Since you're watching this video, we assume you already heard about the incredible which is like ChatGPT work. They are based on language models, which is just a fancy neural network that can do fancy autocomplete. Language models predict next probable words given previous words. Even before the user starts conversing with chatbots like Sparrow or ChatGPT, they already have an input, the so-called prompt, which is basically a description of the conversational persona given by the programmers. This prompt increases the probability that the next words the language model will spit out are in line with this persona. So if here in this prompt we have the word helpful, then most likely the model will predict next words that match this description and will not start using swear words as easily. Okay, so how does this language model converse? After this input prompt, which is hidden from you in ChatGPT's interface, it is your turn to ask it a question. Then, given your question and the persona description, it delivers an answer. Then you say something again, it reads the prompt and your first question, its answer, your second question, and based on this, it continues to say likely words that come after this whole history. And this goes on and on with each iteration from your side and the model's response. You make the model's input longer and longer. The magic thing about these large language models behind ChatGPT is that they are super fancy autocompletes that can pick up patterns. For instance, if you prompt them with descriptions and examples that tell them about an HTML alternative called HBML, they start to pick up the pattern, and the most likely words following your examples are the correct solution to the things you just entered, with high probability. This is called in-context few-shot learning. In context because it is not like the model's parameter updates through learning in the classical sense of weight optimization. It is just that the input already has a pattern in it that elicits correct answers from the model, making it seem like it has learned something. That the model itself does not update becomes clear when we see that this whole history of conversation and all things the model learned from you is gone when you or somebody else opens another conversation with the chatbot, and the input is now gone and the model works just with the prompt and not with the things you had previously conversed with it or other people did. In this new conversation, the history starts anew, so it's not like the model learns anything from past sessions of conversations or from other users. Now, maybe we want to know how ChatGPT from OpenAI works. ChatGPT itself does not have a paper explaining it, but it has a blog post. Here we find out that it is a sibling of InstructGPT, and it was trained similarly to InstructGPT, which has a paper from which we find out that it works very much like Sparrow from Deepmind. And in this video, we would rather present the Sparrow paper since it came later and is a bit more comprehensive, and you'll see why. At the end of the video, we will highlight the differences between Sparrow and InstructGPT, so therefore as much as we know about ChatGPT so far. So Sparrow is Deepmind's version for a chatbot. Interestingly, the Sparrow paper never uses the word chatbot, and maybe it has something to do with the fact that for a long while it was out of fashion to use the term, since research in chatbots was hyped, starting with Eliza in the 1960s, and it failed to deliver onto its promises. So research building chatbots such as Deepmind here with Sparrow preferred to use another term like dialogue agent, or terms like dialogue system or conversational AI. It is relieving to see that OpenAI makes the word chatbot fashionable again by naming their model ChatGPT, and look, they even use the word chatbot in their blog post once. We think it is a pity Deepmind did not release Sparrow, or at least gave access to users to interact with the model like OpenAI does with ChatGPT, especially since we find the Sparrow method, its motivation and paper really cool. Why did this team of researchers think about building Sparrow in the first place? Their motivation was that language models, when prompted to behave like chatbots, tend to say inappropriate things, including sexist or racist statements, and they tend to be opinionated. The language model just doing its thing of predicting next probable words to what was just being said does not have the means of knowing whether it is offending somebody. So the idea with Sparrow is, what if we could define a set of rules and fine-tune the language model to follow the rules? While this sounds easy, it is quite hard to convince a language model to follow rules, and the author's solution here involves human feedback at a smaller scale about the model following or breaking rules. Then training classifiers that will mimic human feedback at a larger scale, and then fine-tuning the language model with reinforcement learning to follow the feedback of the classifiers. And since the classifiers reflect the human feedback, and the human feedback tells us something about the model following the rules or not, we should have convinced the language model to follow rules in the end. This seems complicated, so how to do this more exactly? The authors built Sparrow by fine-tuning Chinchilla, their 70 billion parameter language model that already has great capabilities at producing high-quality text and solving natural language understanding tasks. To make it a chatbot, or a dialogue agent, the authors use this prompt to convince it to take the conversational persona of a, we cite, highly knowledgeable and intelligent AI assistant. They give it its name, Sparrow, in the prompt, and describe what the user should expect from the model. And
so I had a question here, because I think this is directly out of the paper. When they show this as a prompt, do they mean that the prompt goes down to where the conversation begins? Or is it actually prompted with some sample user Sparrow responses? Does anybody know?
I don't know if it includes those 3 words, the conversation begins, but usually everything above that is literally prepended to your first thing that you type in.
But not the rest of kind of a dialogue template that might follow. It just those first 3 sentences, basically.
Those first 3 sentences, and then your first thing.
Right.
And then it responds, and when you ask your second thing, it includes all of that. It's got the whole dialogue trail. And so whatever their token limit is, you're going to hit that once the first 3 sentences and enough you, it have hit that limit.
Got it. Okay. Thanks.
Oh,
Also have an example.
Yeah.
Aaron's got his hand raised and he
Yeah,
came
quick-
in the middle
Oh,
before we got a chance to explain what
sorry
we're
about that.
watching.
No, I just had a very quick question. Do you think they're going to discuss the corpus differences in the two approaches, or is it in essence just a benchmark of the same corpus?
I don't think in this, it's been a while since I watched this video, so I don't
Okay.
recall for sure if they go through it in here.
And you know what I mean by that, like the web crawl.
What's the data set?
Yeah.
But the big difference is not the corpus. It really has to do with how they both start with a fully trained language model that can do like sentences and everything really well, right? It's about training it what acting like a chatbot is supposed to be like, different from just understanding the language. If that makes sense.
And I think there's going to call it architectural differences between them. And that I don't know if I don't recall if we get into it in this video, but if we want to follow up with more of a paper review, they have some architectural pictures that show they have the frozen base of what's the base of this one? The base language, the 70 billion, whatever it was.
The Chinchilla one or the ChatGPT one?
Chinchilla. They have the first 64 layers are frozen, and then they have a number of heads sitting on top of that are contributing in different ways. The classifier she was talking about, these reward modeling layers. So there's some pictures that kind of show how all that fits together from what I've seen.
So one thing about Chinchilla, and maybe at some point in time we should do that paper in this forum. I think, if I'm not mistaken, that's the paper where they highlighted that more than the model size is the data set size that matters. So they were, if I'm not mistaken, they were able
I
to
saw that. Yeah, where they compared kind of how much data that they had in ChatGPT versus Chinchilla.
It could be.
It was like 10 times, yeah.
Yeah. And then they said, well, look, this is a much smaller model. And then on the other hand, there's another model called PAM, again from Google, by the way. So, which is 540 billion parameters or something. And it was highly competitive against PAM or some numbers like that. So again, like, we should probably look at it because that's more on the aspect of not just presenting, what it is doing, but why, like the theory for it as well.
Right.
I guess I have a question on the reward performance models or fidelity, because to me, I mean, it's like I haven't seen many discussions on sort of the weighing of each of these architectural components. There seem to be, I mean, obviously they have some research basis, but it doesn't seem like that's been a priority. It's almost like the priority is this sort of search surface. Like if you could get to 100 or whatever, trillions of parameters, you achieve fidelity. And I guess if the reward, if your reward model was inverse to your parameter model, it would actually start performing worse because of the resource utilization.
So I think we should watch the video and you'll see how Sparrow is set up, and then maybe we can have
that's fair. That's
conversation of what other things we might consider or wonder if they looked at this or whatever.
Yep, that's fair.
Okay, I'll go ahead and play for right now.
Conversation. Now, following this prompt, the user can type in a question or another conversation starter, and Chinchilla will take in the prompt, the user's question, and then give the answer. But Sparrow can do something more than just converse, which is provide evidence for the answers it gives. To achieve this, the authors do a specific update to Sparrow's prompt. We have two more participants in the conversation, namely the search query and the search results. The search query is basically also a Sparrow persona where the language model generates a search query based on what was said in the conversation so far. And the search results is basically a call to Google search and provides a short preview and link to the result. So now this whole thing containing the description for Sparrow, example user inputs and search queries and search results are the prompt which Sparrow always has as input and generates answers with. Now we come to the part where the authors make Sparrow also follow rules. First, the authors come up with 23 rules. The rules roughly cover 3 categories for making Sparrow more helpful, correct, and harmless. Of course, this list is not exhaustive, as the authors themselves admit. One could and should come up with more rules and apply the whole strategy we are describing here on the additional rules. Now, to make Sparrow follow these rules, the authors let it talk without it knowing about these rules. And humans annotate how well it does on different aspects. They tell which rules are violated and whether it should search the internet to provide evidence, and in case it provided evidence, whether it was good. Humans are also given an adversarial setting where they try their best to break the model and make it violate the rules. Here, in a sense, the humans are encouraged to get the worst from the model. And this is valuable training data for fine-tuning Sparrow, since the new iteration of the model should avoid the worst of the last iteration. So this is the human annotation stage, where humans give feedback on how Sparrow is performing. And since Sparrow at this stage is just a chinchilla language model prompted for conversation, it should not do that good. Now the authors take the human-generated annotations to train a neural network to classify how probable it is for a human to like the answer that Sparrow produced. They train another classifier to say whether a response is likely to break a rule or not. These classifiers are super useful because now the authors can train Sparrow with them. For each answer Sparrow produces during training, a classifier can extremely quickly estimate a human feedback for it. Asking humans during training for every example to give feedback would make training last forever, so the authors use these classifiers instead. So the authors froze the last 64 layers of chinchilla and fine-tuned the last 16 layers with reinforcement learning, taking the output scores of the classifiers, enforcing the model to have low scores on rule violation and high scores for the estimate of a human to appreciate the answer. For training, the authors used a dataset consisting of questions and answers from the Explain Me Like I'm 5 dataset, also conversations from the human annotators, and the generations of Sparrow's last iteration, because why not apply this strategy in more stages until Sparrow becomes better and better at following rules and searching the internet to provide evidence.
So Aaron, that might have answered part of your question there then. It sounds like that was at least one of the data sets. I don't know, GPT references it, what their data set is, but this is what they're playing.
Following rules and searching the internet to provide evidence. During inference with the last iteration of Sparrow, to get the best answer from the model, the authors let Sparrow generate multiple answers and give to the user the answer that ranks best given the outputs of the classifiers. Okay, how much better did Chinchilla get after all this?
So I was going to mention that as I was looking through the paper, that this is one that seemed like kind of a design pattern that was kind of interesting, where they would sample, take multiple samples, and then use a ranking of those samples to select the best sample. Use another model to select which of the multiple samples is the best. And then
I think that's awesome. I mean, I just haven't heard anybody really, I mean, this seems so obvious. And it seems like everybody is just asking for some version of this, and the fact that they're comfortable with the preference, sort of, you know, like the preference re-ranking heuristic, basically.
Right. Yeah, that I don't know if I didn't see any references to prior use of that technique, but yeah, that did look.
Because I mean, if you think about it, if you know, like I'll give a very simple example. let's say, it's a bunch of questions around economics, and everybody constantly, checks off on the St. Louis Fed as a source of a piece of data, and it's got some ridiculous, 99.98%, first or second check, then that'll have enormous fidelity, or some healthcare data, or whatever, or some sources like that, Mayo Clinic, whatever it is. It just seems so obvious to kind of construct a high performance fidelity ranking model.
Right, and if I understood it correctly, it decides based on the question whether it should run a Google search, and then it conditions. So that the top responses here were not conditioned, but these bottom four were conditioned on the search results. So it came up with a couple attempts at a query, processed the results, and then conditioned the response based on those results, and then went through and did the ranking. And it also was presenting these citations as as part of the result to the user. So it looked really cool.
Yeah, that looks awesome.
Okay, I'll keep going.
Okay, how much better did Chinchilla get after all this heavy lifting involving human annotation and reinforcement learning to become Sparrow? Well, humans say that Chinchilla delivers answers that are plausible 61% of the time, while Sparrow's answers are plausible and supported by evidence 78% of the time. This looks good. Chinchilla breaks rules 20% of the time, while Sparrow only 8% of the time. But what I love about this Sparrow paper is the extensive evaluation of the models. Surprisingly, fine-tuning Chinchilla to become Sparrow reinforced some of the language model's stereotypes. Just to give you one example, the scores of Sparrow are worse on the Vinogender dataset measuring bias towards gender than for the baseline Chinchilla model. Now we know about Sparrow, let's highlight its differences to ChatGPT. First, Sparrow was prompted and trained to deliver evidence for its answers when needed by searching the internet and providing the user with the link. ChatGPT cannot do that. ChatGPT is also a prompted language model based on GPT 3.5. It was also trained through fine-tuning on conversations provided by humans. So humans rank the language model's responses, and this data is used to train a classifier modeling how a human would rank ChatGPT's answer, much like with Sparrow. And fine-tuning with reinforcement learning uses this information provided by the model for estimating a human in the loop and therefore trains to provide better answers. But ChatGPT misses one very interesting component that Sparrow has. Sparrow also had training from a classifier trained on human annotation, telling it how well it can follow a set of rules. So in a sense, ChatGPT is like Sparrow, but without the capability of searching for evidence and without rule following, which makes it a bit underwhelming. Hey, Miss Coffee Bean, maybe Sparrow's conception was more far-sighted than ChatGPT's, but at least we have access to ChatGPT and can play with it. Regarding Sparrow, we can only look at the paper and dream to play with the model. What a world! We have models without detailed papers, and we have detailed papers without model releases. Should we even start dreaming about model weights and code releases? We hope you enjoyed our then for the baseline Chinchilla.
So I'll stop it there then. This one, I was kind of surprised at that there wasn't more improvement in those two dimensions of plausibility and rule breaking.
Mm-hmm.
But certainly a step in the right direction. I'm going to stop the share then.
Roger, do you have any idea or know why Sparrow has never been opened for people to try?
No, I haven't heard anything. I mean, the paper explains the architecture fairly well. I would guess that this is Deepmind, so this is Google, right? So this is going to be the type of internet search we're going to have in the future, and Google may be a little more interested in controlling that. I don't know. That's just speculation, obviously.
I'll also say, though, that you need a decent amount of hardware to run a big model like this, even for 100,000 users, let alone 1 million.
Yeah. I saw something that said that these interfaces are somewhere between 10 and 100 times more expensive than a Google search.
Yeah, I mean, I attended a presentation that kind of broke down the back end, and they said that ChatGPT has about 50, or had, I mean, it's probably twice, or on its way to twice that, 50 petabytes of storage, and that's for its 175 billion parameter model. So, and then in theory, they said the next one's supposed to be, 500x or whatever, which asks, I just have a bunch of practical IO hardware questions that people don't seem to be answering. There just seems to be this very black box, Watson kind of feel to a lot of this. If you guys remember Watson 15 years ago, or 20 now, I think it's 20 now, which is kind of sad. But that, it's just like, it's magic. Don't worry, it's happening. Don't ask all these like icky questions. We're smarter. And I mean, at a certain point, they're going to have to allow for some kind of externalization to this, to what this is. I mean, business decision makers aren't just going to say, throw it into Watson 2.0 because magic's going to happen. But
it depends how they.
I think what OpenAI is hoping isn't that people will incorporate ChatGPT into their product, but rather just that their workers will use it for X, Y, or Z, to help them with writing marketing material or whatever. And so I'm not saying I have an opinion as to whether or not that strategy was successful, but I'm saying OpenAI, they clearly don't, they're not trying to prove anything. They just want to sell their API and get lots of people to buy it. Just like GPT-3. They never proved GPT-3 wasn't biased, but there are companies who are paying for GPT to generate, language.
I mean, I think if we're suggesting sort of and I'm just going to use my, I'm an old enough guy, I think, like the rest of you all here, that we've been through enough enterprise wars, that if you're sitting there with a productization strategy, and there's obviously a Microsoft partner there, and you create your sort of, Office 366 GPT version with a little, bar on the side, you're going to have a fidelity, right? Like, I can see the Word version of that. The moment it's an Excel version and it's financial people, it's like, this just doesn't cut it. I mean, can you imagine people doing, FP&A, and they're like, well, I use the GPT, and it's like that excuse doesn't cut it, right? The first CFO that gets smoked for that is just, like the whole thing goes up in flames. So it's just, to me, there just has to be sort of like an acceptance that there has to be a fidelity here for a professional. And I kind of seen the same thing with Meta, or just a lot of these cycles in the last 10 years, where people get way ahead of the skis on the tech side, and they just sort of think, hey, all you old people in the tech debt world, we're bringing in the revolution. Don't worry, we'll have a place for you.
Trust us, right?
But,
yeah.
I think if you look at it, it in its current form, it is close to being something that is a productivity enhancer, right? It doesn't like replace anybody at this point, but it turns out that there's Visual Code, there's a GPT plugin for Visual Code.
Yes, code, yeah.
Yeah, the Codex thing.
Yeah. And it doesn't get everything right, but it can take care of, it can help with the bulk of the coding.
But to Aaron's point, that code is the developer's responsibility. The developer is the final say-so as to the validity of that code, not just taking that code verbatim and just shoving it into running your banking system or something like that.
That's right.
Yeah.
So I understand the point of view, but I think the same thing would be true elsewhere. So if I run a marketing department and you say, give me a marketing spiel for blah, 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 I expect my employee to say, yeah, that was actually a really good answer. I didn't touch a word, or to say, no, there were some things that I need to clean up. And if you tell it, give me Excel formulas to calculate blah, 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 it's the same thing. If you don't even double check the formula, look at it, then you're not working for me anymore. Just like a program.
No, and I get that as the internal failure, and that often is caught. It's caught today because of the multi-stage audit process we go through, right? I mean, you start your close in Workday 2021, and then you start your real close and, Workday 1 of the next period. And, then your auditors are basically 2 teams running in parallel. I mean, so it's like we have this sort of, very mercantilistic labor system when it comes to a lot of financial information, but it does work because ultimately, unless you're running one of these, once in a generation world-class grips, it's like, there's tens of thousands of entities that are reporting out on a regular basis pretty cleanly. And if the explanation of the use case for some $1 trillion market cap is it's just going to pump out more marketing after a consumer tech wave that's saturated, I'm like, okay, I don't know if that's worth that. If it's going to be adding this quote unquote transformational productivity, well, then it's going to have a fidelity model, right? It's like you just can't. It seems like what they want is the sort of load and go, but it's going to go everywhere. And it's like, well, the whole world's not going to sign up for a load and go model in every function that we do. It just doesn't make sense. We don't do that today, and we have friction that we're not happy with today because is so much human intervention. And so if we're looking for things that are going to automate things, I mean, this is why, to be blunt, like I've rolled out over the years, systems like Pega, big, these nasty BPM systems, which, it sucks. I mean, these are, and not because it's technology, well, technology kind of sucks, but it's not because of the results suck, because results do work, because if it didn't, none of your insurance claims would work. None of the, that's how the world really works, is with these type of systems behind the scenes. And if what we're saying is like a GTP kind of magic version, I'm just like, I don't see how that happens. Not with this black boxing of these algorithms and machine learning models with no domain expertise involved. It seems to me, and I've always come back from this expert system side, like they're really fighting a religious war against people who have been on the expert system side, whether they even know that's what they're doing. That's what it feels like. Because to me, if you bring some of those expert systems people in, it's almost like a validation layer, and maybe even help optimize some of those approaches, which haven't really been invested in, then I think you might get the best of both worlds.
But any system that you bring online, right? Somebody's job is on the line if that thing goes south, right?
Yep, absolutely.
So somebody would have a vested interest in verifying, regardless of how it's created, whether it's, a deep learning model or a bunch of guys, throw 10,000, donuts and coffee in the room, and, the code comes out the backside. However it's done, somebody has to validate that to make sure that it does what it was supposed to, and, it doesn't do it in a way that's detrimental to the organization. So I don't think that goes away in any of these schemes, I guess is what I'm trying to say.
I guess my challenge is that if it's a black box, one of the reasons I would say the Visual Studio one and AWS one is AWS had the Visual Studio of cloud engineering, which was cloud formation, basically. And Visual Studio is the Visual Studio of building apps. And I'm not saying it's the only one, and there's a whole Java ecosystem on the other side, which is fantastic too. And if you work in certain industries, that's just all you're using too. But those worlds, in some ways, and the Azure version too, so these big ecologies had a very transparent development and or deployment architecture, however much automation they used. And they use a hell of a lot of automation. We don't maybe give it credit because we still are, clicking things, but when you look at what's actually occurring in terms of what you used to do 20 years ago in an IDE, or we used to, roll your own VM even 15 years ago.
Oh yeah.
enormous amount of automation. And so, you know, the fact that it's not AI bells and whistles is that, to me, that's almost secondary. It's highly, you know, pretty intelligent, I would say. But it's very transparent, right? The moment there's something missing, a log gets flagged, you know, X, Y, or Z happens. Like there's an instrumentation there that tends to be very, very transparent. And I'm questioning a very untransparent layer with no logging even. I'm just sort of like, okay, that's weird. I mean, I'm just, you know, unless we just go in. Go ahead, sir.
Sparrow's doing a little bit to address that in the sense that they're providing the citation to the information that supports their conclusion.
Yeah.
It's not quite the same. I was thinking it was something that would explain, like, how did you arrive at that conclusion? What are, in your models and your probabilities, what are all the things that affected your probabilities?
Right.
So you predicted this, and that's not what it's doing.
No, there's no like decision tree or anything spinning out of that, right?
Right.
Because that's an expert system. No one wants that anymore, right?
Yeah. Well,
so if Sparrow or ChatGPT could write the expert system, then it might be okay.
I actually totally agree. I actually do. You know, because ultimately to do that, they basically vacuum clean up the expert system market.
Right.
So a whole bunch of people with their LinkedIn's with 20 years experience would be now there, and people would be like, oh, that's fine. I saw them at 10 conferences, done. Right. Like, and the thing would take off.
Hey, COBOL guys are getting money, you know, so.
But Aaron, I think for me, I don't want to be too discouraged about the future. What we're at right now is a language model demo stage, and that's all it is. And and it's, you know, it's moving pretty fast. So I think it's expensive computationally to do this right now. You're not going to use Sparrow to do, you know, what a calculator could do. You're not going to use it to do what an accounting system could do. But there's a different class of things that it's doing better than.
So there are a couple of things, Roger, and so like 3 things to consider, right? So one is that the fidelity acceptance is dependent on whether it is worse or better than human error. So while I understand a logical, a sequential logic program will always give you the same result, but it may make an error if, for example, in the space of legal space, right? The laws keep changing, new results keep coming out. In those scenarios, a human will make a lot more errors versus a machine with especially one-shot or few-shot learning can accommodate and learn from that and cite those as the reasons. And by the way, just as an example, the ChatGPT is being used very heavily right now, or similar programs in legal space for I don't know if you have seen those announcements. It is doing better than humans in passing their bar exams. It is already approved in some cases, and I don't know how, and I don't know the legal system here. So a chat assistant is guiding the defendant or plaintiff or whoever, to respond based on the AI system responses, guidance. So this just.
But that's you're never going to see that in the existing court system, because the existing court system is structured legally around representation. You have to have a whole new set of precedents. Yeah.
They don't even allow digital devices. So I don't know.
Exactly. Yeah. There's no way that's going to happen.
Well, I don't know. No. So that's where I've gotten the first point, which is the acceptance level. So once it crosses the acceptance level, and then the third point is that it's all driven by how much data it has. So the more data it gets to absorb, and of course the technology also moving forward, you know, the point that you made earlier, well, yeah, you know, you just throw in more parameters. Do you even understand it? I don't know, but there is a lot of work going on to understand the theory of learning and the optimizations that can help you drive towards successful outcomes, either based on the understanding or based on some learning that we had a century ago, when we suddenly, like, you know, we were dealing with atoms and then trying to understand the macro properties of physics, physical world. And then, well, I don't know how the atoms diffusing into each other.
I mean, I guess my only question is, like, if anyone's ever gone to a significant, you know, teaching tier 1 hospital in the United States or typically abroad, but especially in the United States, those specialist departments use expert systems. So if you're in the oncology department, they'll have expert systems in there, and that's like, this is like BAU. I mean, this is like not. I mean, it's cutting edge for non-teaching hospitals and stuff, and that's like a funding issue, whatever. But it's not cutting edge tech, right? It's sort of built into the budgetary plan as part of opening up one of those wings, and those systems have are pretty robust. I mean, especially the way they're trained, right? Because they're trained on real data. They're sharing between teaching hospitals and large scale NIH studies and or drug studies, FDA, and research papers and expert laboratory work by ranked professors that are specialists in those fields. And so they're not perfect. Obviously, nothing's perfect, but they offer in that model, because typically when they do diagnoses, you'll get a pile of these experts and tell them that, when they're all telling kind of like we are doing now, but their version with the Blackboard type app, and they've got all their data up, and they'll bring up 2 or 3 of the different sort of vendor, like one from McKesson, one from from Ceridian, one from et cetera, from the different hospitals, talking about it and seeing what the results are. And when they all sort of mesh up, then they're like, okay, well, that's the best call we have, right? That's like maybe the best call humanly possible. And I don't know how you're replacing that. It just doesn't add up. Like, why would you replace that?
So Aaron, if I can jump in, I'd like to shift us. We've spent a bunch of time. I'd like to shift us away from this fidelity conversation. You have a point of view.
Fair,
okay?
sorry.
I think it's fair. I would say you probably need to think beyond all or nothing, black and white. This isn't about, do we just throw out the expert systems? You may have these other systems that then get used, like you're saying, you look at 3 different expert systems and you look at this other system. I have a daughter who has medical conditions, and there may not be that many people who have her combination of problems.
Yeah.
And for any one of those problems, I'm sure your expert systems at the hospital are very good, but how do you deal with the intersection of these 2 rare conditions? Yeah. Right?
Yeah.
The AI may be wrong, but you may want to at least just see what does it suggest.
Yeah. Well, that's fair. That's totally
smart
fair.
Doctor, right?
Yeah.
So I think there's a lot of things, and I'm not discounting the importance of the fidelity conversation. I'm saying that this is more of a deep learning study group. So if we want to talk about how to achieve fidelity, I'm more interested in that.
Yeah, and that's what I was really trying to mean.
Or businesses will buy it. Maybe we.
But I guess my only point was driving to the understanding of some degree of openness, because I don't know how you get to these integrations or these coupling, let's say, of a multitude if these systems stay extremely black box in and not just in their engineering, but in how they seem to be even instrumenting their fidelity, because
there are lots of people who are researching machine learning interpretability so that they can get at some of these questions. I don't know how successful they'll be with something like large language models, but they are working.
That was the question I was going to ask, is, are we aware of any papers that are addressing that?
Right now, I feel like the techniques don't really work for large language models, okay? So like if you do tabular predictions, you can sort of say like, okay, I have these 20 inputs. Let's use like a medical example, right? And so you can say like, if their BP had been 10 points lower, how would the prediction have been different? Or if their, blood sugar had been normal instead of abnormal, how would the prediction have been different? You can kind of do that with tabular.
Yep.
And you can say like, if you're predicting the cost of a house, or whether or not you think someone's going to default on the loan, which inputs were most important in saying reject that loan. When you're doing autoregressive and you're spitting one word at a time, it's a little bit harder. You can do that for any one word, but it's a little bit harder to say, how did that then influence the whole sentence or paragraph or whatever, right?
So
like the regression of the vectors becomes more complex as you get higher dimensionality. Yeah, because you're getting higher dimensionality and it just starts going sideways, actually.
Yeah.
So Ted, what do you think of using as a proxy for that, this idea that it's looking up Sparrow is looking up references and then conditioning the response on that.
Well, I think Sparrow will potentially be a model that you want for like your business use, where your marketer is including some language, or your whatever person, you know, in some department is doing something. Could be a finance person looking up some way to treat depreciation. I don't know, whatever, you know. But ultimately, that's not going to solve the tough problems, because like if Aaron's talking about, you know, a surgeon like making a difficult decision, that's not going to live on the internet. There's not going to be a Wikipedia page that says what do you do for this super complex, you know, case.
Even basic stuff. I mean, because of the liability. I mean, you just aren't, you know.
Yeah. So
you know.
so that's where
I guess it was more that, so to contrast this again, I was hoping that this idea of kind of making it explainable, being something that somehow propagated the gradient back to particular documents, right? That I chose this word because of that document, right? And that isn't what's happening. Instead, they're running a query, getting results, and then conditioning a sentence generation based on that, and then using a separate model to rank it to see if that was a good explanation. Did that follow or not? And so in a way, you get some explainability out of that, but it's not a direct, you're not following the gradient back to the inputs.
Yeah, I don't think you're ever going to be able to do literally, well, I don't want to say no, but I think the people at Anthropic are doing a really good job of asking these types of questions and looking. And so one of the things is their transformer circuits research work is really about sort of following the gradient back to see how did it actually come up with that. So one possibility is that down the road, they will say, what we thought was a very complex process with this transformer stuff or whatever, we may be able to look at a certain number of activations and say that this particular output is actually sort of the equivalent of this linear network with these particular things. Now, that's not saying that all outputs would be equivalent to that, but this one particular output is, and we know how to do a certain number of interpretability questions on like a regular linear network, right? So if they can kind of figure out, you know, some of this stuff, I do think people are doing, you know, work. But even still, like, I mean, there's a reason why, like, you know, loan software still uses logistic regression. I mean, and I actually think that on the one hand, it's a good thing, and on the other hand, it's kind of a bad thing. So, you know, right now, because I think the world is very imperfect and there's lots of biases, you probably want people using logistic regression, because anything else is going to be highly biased or whatever, right? But in terms of accuracy, I think we are well past logistic regression. You just have to figure out how do you train it on something that's not biased.
And the other thing, Ted, and I think in that case is you have to be able to defend the decision. And it's a lot easier to do with logistic regression, or, you know, some sort of like an alpha beta tree, you know, some sort of tree structure or something, decision tree versus, you know, oh, we just put it in and, you know, it said 85% probability you're going to default on the loan. I can't tell you why it said 85%.
Right.
That's why we're denying you, but you know, it came up with 85. The system said that is never a satisfactory answer, you know, and nobody wants to bet their job on that. So.
Yeah, but again, I mean, I don't know, maybe I'm being a little silly here, but like in a world without bias, I think that the more complex models would do a better job. And there's some people who get loans who otherwise wouldn't from the logistic regression. But I fully acknowledge that because of the color of my skin, I might not get the loan. And so I don't want one of those systems. I want the provable one where they have to defend why they didn't give me the loan. So
yeah, there's that. Plus there's the whole issue of are you using the color of my skin as a determinant in whether you're making, you know, you have to show me you're not, or something like that. I should say in that question.
Yes. I acknowledge we live in the real world.
Yeah. Well, not unfortunate. We do, and we have to The system has to meet our needs, not the other way around.
Well, I do think one of the interesting dimensions here, I know there have been some papers on this, which is, sort of chain of thought, linguistics analysis, because I think based on the classification, if there's a way to align the classification and transformation to the chain of thought of the question, not the question, the reasoning model, then then you can start to sort of classify, sort of burdens of questions based on their type. Like it's almost like a phenotype, right? Like you can, whether it's a financial, it's almost irrelevant what industry domain it's in. It's just like you're asking a question, like if it's a when then if it's a SQL clause, then that fits a classified type. If it is a time, I'm going back, I took like two linguistics classes in college like 35 years ago. So I'm just like, I'm going to sound off by, I'm going to have the same accuracy of ChatGPT on this, but that the relationship to each of those reasoning types, if you could have that calibrated set of transformer classifications, then I think you could start to have you could start generating confidence, right? You can basically start to index, and even have the system index in theory.
So people have been making that argument for years. What I can tell you is that the conventional wisdom in deep learning, is that you as a human can't create enough categories and enough accurate categories to do what's needed. In language, it's even harder, but let's just talk about computer vision. You cannot you can create a program that will have filters that you manually define, and then you can say, using this combination of filters, this is a dog, this is a person, this is a tree. And I guarantee you that these like million parameter convolutional neural networks are going to kick your butt. That's the conventional wisdom, right? Yeah. Because they're training thousands of filters, and they're doing it on millions of images, which you hope are correctly labeled, right? That's where the humans come in. I'm not saying humans don't play a role. Humans have to play a role in curating how you train this thing. But the conventional wisdom is that you as a human being do not have the manpower to create thousands of filters.
So I think I do think this is always this critical juncture of a discussion where it sort of stops. I've always believed, going back to the mid 90s when I started in this sort of space, that the first moment value it's sort of proven because it's math, really, like you said. But when you get to, let's say there's a regression, it's like a logarithmic, it's like Gaussian, really, in terms of the way problems become complex. So as you get to the second, third, fourth moment, those training cycles typically start going sideways pretty quickly. And as you start not just requiring fidelity, but as you start to drive to the determinant variables, that's where you bring in typically not even single, it's groups of human expertise. So if it's a manufacturing line and it's the extremely sensitive, high tolerance, specialized steel that's being made, for space, blah blah blah, for extremely unique customer, it's like any the degree of inspection, and risk tolerance is very, very fine, and you tend, as you move into that 10, 20, 30 moment kind of question, you're cycling through this because it's binary, like, because if this thing goes sideways, no one who wants a challenger,
I'm not sure what you're saying, because it's like, if you're saying there's this specialty steel, then yes, I agree, it has to be human inspecting it, because we don't have a million image data set of specialty steel. But if it's just a regular screw, I say that we can build a CNN that will detect defects in making a screw better than you can design the filters, because not because you couldn't do it. If you had the long enough lifespan and were willing to dedicate your time, I'm sure you could beat that model. But nobody's going to do that.
But it's
Whereas
irrelevant
you can train a
because we're
computer
willing
on a
to
million
accept.
samples.
Yeah, because we're willing to accept at Home Depot a junky screw made somewhere else or a place that makes junky screws half the time anyway. So this is where it gets, I think, a little tricky, is that I think for the junky screw industry, this will be amazing because they could build a higher quality screw. They can move up the screw food chain. Sorry, it's not a little weird there, but they can move up that food chain in quality at probably even a lower price to some degree, a few percentage points less. And that will, and so that might be an interesting argument, that there's a whole bunch of bottom third quality products, services, things we have all over the place. These tools might be somewhat revolutionary to move them somewhere to the middle, maybe the lower third, up the high end, middle third. And that might be the sweet spot. But it seems like there's an enormous amount of VC and marketing, blah, 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 like there always is, that's, focusing at like the top of the food chain. And I'm just, and there's just a natural feeling like, whoa, you're shooting a little high. Why don't you go after the bad screws, or whatever.
But I don't know that people are shooting at the top of the food chain. I don't know that ChatGPT is designed for some mission critical surgical note. It's designed
with a 29
for
billion
bozos.
Valuation already, which likely means it's a $300 billion company when you get to full post-recession yield curve swing and the next flush up in the bubble. I mean, it's like, and then, everybody else goes, I mean, you got to be earning some returns at some point to justify. I mean, that's a lot of EBITDA. You need to be solving some high margin problems.
You're only going to get those returns by selling to the masses, not to the surgeon that's writing these. It's not going to write surgical notes for people. It's going to write bozos who want to start their own cupcake business. That's who's going to use it.
Yeah, if I think about it and why Microsoft is so interested in it, I spent, a decade as part of the Office team and things like that. And our typical user is not, a perfect linguist, right? The idea of all that work we put in, all those tools, and specifically in PowerPoint, why we put in all these features so you could just say, oh, I want a picture of somebody dancing, and we show you 500 pictures. You say, that's the one. And it's not a perfect picture, right? It's good enough to get your presentation and make your point. So I think that is where, and we were bitching about, oh, we only had 97% of the market. How do we get the other 3%? No, literally.
Remember the law firms that stayed on WordPerfect till about 2008, like the last crash.
Yeah. How do we get that guy?
Like,
no. That's why I didn't work on Word, because it was just no. Anyway, but we would spend just all sorts of times, like meetings till 2 a.m. about how can we get up 1 more percent, of market share. From 96 to 97% penetration.
So I'll give you one example.
Great team and put them on other products.
Yeah, but you're never going to get that. And that is that I think we figured out we were never going to get it, and that was just, we were okay with that at the end of the day.
So I'll give you one simple example that people sometimes those simple things lead to huge productivity gains. Let's say Excel or something, right? So you put the first name and last name as one name, and you want to split it as first name and last name. Put the full address and get the zip code, and it could be anywhere in your whole, whole sentence or that column, right? So people are like, well, if I get even 90% of it out with ChatGPT, I'm happy.
Yeah, and you know what? There is this thing called like the Postal Service that will probably still get the box to the right place or whatever.
Yeah.
Because there's a human there. This guy's going to go, he's driven this route, and he knows that, they always screw up the addresses, or they put the box number together with the address, or some sort of screwy combination. So there is a secondary thing, and that's good enough.
Yeah, I thought that was a kind of an interesting thing about the Sparrow architecture, is the way that they're using the human feedback in the reinforcement learning. I found a place where I think it was like less than 100, or on the order of 100,000 conversations that had been reviewed by people. that, you know, that had made this shift in what was it, plausibility and accuracy, whatever it was. So it's kind of a way of, by creating those classifier models, really leveraging that human feedback, to affect the results.
You know, I read something on ChatGPT recently, which was kind of scary, where some professor, I don't remember, at some, you know, top flight university, somebody had done a paper essentially using ChatGPT, and they asked him, you know, for like his junior class or whatever, some sort of mid-classman, would he give it, you know, what grade would you give it? And he was willing to give it an A. And he said, they said, well, you know, why isn't this showing, you know, is this showing, you know, enough? And he goes, yeah, it is. And we're not looking for, in the bottom line, he came out with this, we're not looking for perfection. We're looking for a logical flow from A to B to C to D to E to justify your conclusion. And you can, how you get there, you know, is where the creativity comes in. So that was scary, and you know, it made a lot of sense at the same time. So.
Would it be interesting? Oh, I'm sorry.
I've been amazed how often it seems like ChatGPT in particular makes things sound plausible, sound reasonable, but it imagines lots of stuff.
Yeah. So color me the optimist, but you know, if I'm the Shakespeare teacher, whatever, you can't bluff me with fake facts that you made up, right?
Right.
So I'm actually the optimist that I think that something like computer generated text, as it gets better and better, is actually going to improve education. You know, right now, I don't think teachers think that you using a spell checker is cheating.
Correct.
Right? They used to take points off for spelling mistakes, and you almost never have to take points off for spelling mistakes because people have spell checkers. So I would love it if everybody gets this little boost where you can have a well-formed paragraph with good logical flow automatically, because if you don't, the thing's going to review your paper. It's like, you know, you're probably not going to get an A because like you made this thing in your thesis and you never actually said anything about it later. You need a paragraph that defends sentence 4. You know what I mean? Like, I think,
but are these language models?
Thinks that this will help.
Yeah, but are these language models really capable of following thoughts throughout the sentence? I mean, they're good at, you know, find something in the internet where people have said certain things and then just basically reincorporate that into what you're doing, which is different from, you know, what you want is a logical argument. I mean, it's word matching and word babbling. It really doesn't have a concept of what's going on.
Well, I think you and I could disagree as to how far they are today, but I'm saying even if they're not there today, they're going to get a little bit better, you know. And
but they're not. But there's no intelligence aim there. I mean, you know, there is no aim to, you know, even like, for example, I remember a while ago we were looking at general adversarial networks and looking at images, and you could see like the pictures were locally consistent but globally inconsistent. So you'd see it's a face because they put the nose at the right spot, but on the other hand, the ears didn't match, or these subtleties, and it's like. It's the uncanny valley problem. Something is close but not close enough, but it's really disturbing because it's not close enough.
Yeah, no, I think GANs have gotten better, but I'm not arguing with you there, Walter. That's why I'm saying that I think that this will elevate education because the computer won't be able to do what you're saying. Only humans will be able to do it really well, what you're saying. And that's the difference between getting an A or not. So today, what we might consider a D is sort of like bad grammar, this, that, or whatever. I think the bar is going to be raised where that's going to become an F in the future because, geez Louise, you didn't even use your sentence checker. Right now we have spell checkers. You didn't use your sentence checker. You didn't use your paragraph checker that's in Microsoft Word to at least, you know, eliminate these obvious problems.
Or your logical consistency checker.
Yes,
but see, I mean,
get the logical consistency perfect.
But this does raise a fundamental question, which is, and it sort of was highlighted. I was in a meetup group, just sort of randomly started going to this group that they basically go over all these classics like Cicero and, you know, the Greeks, blah, 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 blah. you know, and to be very honest, I mean, I sort of read this stuff a little bit when my kids were in high school. Well, I was able to trick my oldest daughter into suffering Latin for 3 years. But you know, that's
You're a terrible parent, Eric.
Yeah. Well, you know what? She can write her ass off, actually, which
Yeah,
is pretty
I'm just
funny.
giving
Like
you
a
a
lot
bad
better
time.
than I can. But but what's funny is, and I kind of had to help her, and then I had taken like a year of it in high school, and then you know, and so it's like I never really, I had this like, you know, better than surface, but I wasn't deep, and I was always just like half a hour ahead of her. But and then I started taking, you know, or I started going to this meetup, and I had to actually start reading, not in Latin, but you know, whatever, all the translations and transliterations, whatever. And I just realized, like, and I started working. Like, this is work. Like, I'm not saying we don't do work every day, but I mean, like, this is a little different. Like, you really are getting out of your comfort zone and having to process the logical relationships that are being defined, right? And this is thousands of years ago, but the language, it's pretty clear language. It's just dense. And I'm realizing people can't do this anymore. I mean, I don't think it's impossible. If we said, if we can't do this in another year, the world dies because of an asteroid, you know, we'll get pretty close to it because people don't want to die. But that's not happening. So our logic, right? And I would say our spelling sucks like today because we have to have checkers everywhere. And I think we do run this unique risk. And this isn't me like, oh, the good old days kind of thing. It's just, you know, but in the same way as, you know, you could meet a lot of people. I remember growing up in the 70s who, you know, didn't have fancy degrees or anything, but they knew algebra. I mean, they actually, like, in the old school way, you know, like dad's or grandma's little algebra book, you know, that little like half book, you know, that they had in 8th or 9th grade. And they really, I mean, they actually knew this. And it's just, you can't meet people who really hard. I mean, outside of someone who works in engineering or science or computer science, or finance, let's say. And I do think there's a strange risk that that with a lot of these tools, and I think it's inevitable. I don't think anything's stopping this, but I just think that there's a fundamental risk that a lot of our ability to be coherent and cogent and have developed communications at scale. That doesn't mean little, you know, this family doesn't do it, or that school, or this little area, or whatever. Or this community, but just overall, like this broader degradation, just like in manners, right? Like, I still hold doors open for people, even though my grandparents have been dead for, you know, almost 40 years, because they would, you know, respond in ways we define fairly illegally now. If I didn't do those things back in the 70s, you know, and of course, you just don't see people, you know, like sometimes people, they don't even say thank you. And of course, I'll do the old school, like, you're welcome, you know, and some people are just like shocked that you're doing this. Like,
so
it's
Aaron,
just almost, you know.
Yeah, so
Yeah,
Aaron, so I think you're touching on two different things. I mean, you started with a different thing, but then you moved to the cultural shift. So cultural shift may or may not happen. Maybe technology is the reason why that is happening, but, you know, because less socializing and whatnot, right? There could be many other factors than just the AI part. But staying on the previous topic, I mean, I personally think, like what Ted was saying, that, oh, what used to be D or B is now F. I think it's way more impactful than that, because someone mentioned about the chain of reasoning and the emergent properties and few-shot learning. Like, if you combine all of those, and this is just the beginning. I mean, in my opinion, in my mind, if few-shot learning with chain of thought reasoning, with the third thing that I said, and I'm driving, so sorry, I forgot also.
You're doing great. I couldn't do that.
So those three things combined, in my opinion, is just the beginning. And if this is just the beginning, then a lot of people who out there, like, I wonder about my son, and you know, I think this group knows, and we're pretty open. My son is on autism spectrum, and I'm pretty sure that there's, you know, education is not going to make a difference for him, given, I mean, not as a spectrum, so, you know, not every kid is same, but I think, you know, I need to think something else for him. Maybe, you know, he can just do music or something else, but education, math, that whole logic thing, that's not going to serve him. But that's maybe because of his condition. But if I remove that, I see that happening now to the majority of people. Like, I think all this education, because they don't need to learn, because ChatGPT or someone out there right now, yes, somebody needs to confirm it, that is right. But I wouldn't be surprised if in a year or two, majority, and when I say majority, like 90+% of it is all correct. And that's way higher than the average human capabilities. And I'm talking about math, I'm talking about.
I agree, Dave, that it's that we need to be thinking about the trajectory, not at the point that we're at right now.
Yeah.
And if you project forward 2 years, 4 years, 10 years, there's going to be a lot more capabilities going to blow our minds away. If in 2012 you could log into ChatGPT, it would blow your mind, right?
Yeah.
And I think it's going to be the same thing in another 10 years. So the more fundamental questions I think about are, our children need to figure out, this is going to be a huge productivity boost. How do we, as individuals, stay on top of that productivity boost and not get left behind on it? And then the other one is, we're going to run into some sort of limit. Information age stuff is only impactful if it's cheaper than the human, and if it's lower resources than the human. And we're already getting into these massive scales that, how sustainable is that growth at those scales?
Right. But then that's where the effort is going. So you're right about that. A lot of times people tell me that, oh, big companies can afford that. I'm like, no, they cannot afford it. The way it is going, they cannot afford it very soon.
Not another 5 years. Yeah.
Yeah. So they are investing very heavily in the core foundational theories of deep learning. Like, you go to any of these places, Deepmind and Google Research and some of the top-notch universities, their main focus is not what we discuss at the application level. It's not at the interface level. It's at how do I understand the system? And if I can understand the system, then only I can make it cheaper, better, bigger, or broader, or whatever.
So that's one dimension that you can do, just making things more efficient. The other is looking at what are the hardware and energy.
Because if you get to hexabyte level platforms, which it sounds by the theory that's where they'll be in a matter of a few years, and you need to have a handful of competitors in that space, plus a handful of government entities in the world, blah, 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 whatever. Let's say the 20 to 50 places on Earth that can do that, most of which will be either black box or not public. And then you'll have some kind of consortia versions that are sort of glued together, top Ivy schools or whatever, top, Berkeley, Stanford things. And then you'll have, like, let's call it the, like the Joe Blow version. You'll have the Home Depot Five Guys version out there. It'll be a very weird world, because your interface will be, to a black box, which has all the scale, and then to more tailored environments which don't have the scale and run into whatever limitations that equals. Especially probably some parameter to storage or whatever. It'll be some kind of efficiency. And you bring up a great question on resources and energy, environmental, blah, blah, blah. Just like we kind of gotten into that in the sort of data center ramp up of the last decade, right? In the last 10, 15 years, the big, 10 cloud providers and biggest couple hundred companies.
What happens when, I need 1,000 times as much compute power as I have right now, in 4 or 5 years, when it sounds good.
Yeah.
Hey, as a matter of order, I notice we're running over a bit here. Do we want to wrap up? Do we want a quick discussion on what we want to do next week?
I think Ted proposed something on the chat.
Oh, did he?
There.
I didn't notice that.
Yeah, so some.
I just put it in a minute ago.
Yeah, I was thinking, Velo is good, or Vino is also good from. That's the quantization stuff, right? From Vino, and this is Velo, which is different. Training, versatile, and optimized by scaling up. Okay.
Where are you at? Where are you posting stuff, Ted?
He just put it in chat.
Oh, in the chat.
Zoom chat.
Zoom chat.
Have you guys ever done anything on like AI on a chip type stuff yet, or no? You haven't done that.
You mean like tiny ML type stuff?
Yeah, or TPUs or blah blah blah.
Yeah, we've
Just
done
because,
some of that. Yeah.
okay, because the
Yeah.
only thing I'm thinking is as these models get to whatever
Mhm.
defined success equals in the next
Hello.
2, 6, 8 years, what's typically happened is then everything flips to silicon, right? So, and to me, that's where things get. I mean, that's where to me they can actually get extremely interesting.
Yeah, well,
Because now,
now it's a useful thing that you can carry around in your pocket or something.
That's
like
right.
that, or
That's right.
your watch, I guess, whatever the micro.
Yeah, or embedding in medical devices or putting into avionics or whatever.
Back to your thing, we
industrial
were
computing.
talking about a doctor, right? That
Yeah.
he's got a case and it's really difficult. Maybe something, he does a probe and it says, "Oh, I just took this reading and that reading. Don't go down don't go left, go right." On the decision tree or something like that.
And I think Apple is working a lot in that space by, one of the principles that Apple has is not to send data across as much as possible. So push all the ML inferencing to the edge device.
Yeah, to the edge device, yeah.
Yeah, so
but also, I think we want to think about the fact that most of the compute is in the training of these models. I know it's still expensive to run them, but it is kind of a different problem. Like, Jerry, you did that one video on Tesla's supercomputer.
Yes.
That's really an architectural decision for training because they needed a lot of bandwidth for all the data for their training, right?
All the
It's not the same architecture you need for inference. So hopefully we will have some breakthroughs around inference. But at the end of the day, once you've trained that thing, maybe somebody just turns it into an expert system decision tree and has CPU only, if then else statements. I don't know.
Yeah. Or we have a new CPU architecture or whatever we even call a PU.
Yeah.
Right.
Yeah. Some sort of logic. Let's just call it a logic unit. How's that?
There you go.
No, so I was going
old school.
I was going to mention that if you look at NVIDIA's latest 4090, what they say is that, and even look at Google's chip unit, and I'm sure Apple's chip unit and Intel and everyone, AMD.
The TPU4 or something for Google, yes.
But the way they are, Moore's law is dead for many years now. So the only way they are able to make even a little bit better progress than just reducing the process size, now down to 4 nanometers, and they're talking about 3 nanometers. Yes, it's a 25% gain, but the process is not stable, and the Moore's law is dead because they are not able to sustain that. So the only way they are able to do even slightly better is by leveraging AI to find patterns in the use cases, and then maybe either statically come up with the architectural changes or dynamically read out your binaries or restructure binaries so that it gives you more efficient outcomes. So the point I'm trying to say is that maybe at the architecture level, there is some work happening. I don't know if it is going to be as breakthrough as people are thinking. It could be. I mean, I don't know. Maybe something at the quantum, at the atomic scale, they can come up with something based on the observations.
Ted's group did a quantum computing, and that was pretty interesting.
Well, I mean, let's be honest. At some point, there'll probably be QPUs, right? Or something like that in the next decade or two. However Q they are, there'll be more Q than they are C. Let's put it that way, probably, right? And so I think and then that'll be an interesting dynamic too. Is how does Q cross ML, AI, etc. Right? Like, where are these? Are there even intersections that even make any sense? And how would you even make what's the combinatory math to even make sense?
Yeah.
Well, actually, there were. I do remember going to actually IBM has a series of meetups on Thursday. Actually, Thursday, like 2 o'clock my time, so it's like probably noon your time. IBM Toronto, and I can put but they do talk about having machine learning algorithms reformulate laws of how to basically formulate quantum computing algorithms. But they say machine learning stuff. And actually, you saw that like a month ago with this guy who did this study where he basically improved matrix multiplication, and he basically some machine learning algorithm came up with a way to do much faster matrix multiplication. I mean, marginally faster matrix
Yeah.
multiplication.
Yeah,
But,
marginally.
you know, but you know, it scales.
Yeah.
I mean, that's a huge, it's scale for large matrices, that marginal difference is huge.
Yeah.
And basically they basically wrote down and then wrote some sort of machine learning algorithm that would look for ways to multiply. I don't know the details. I read a whole bunch of, actually I read it last night again, and I read it about a month ago.
Yeah. Anyway, we should probably wind up here.